when it comes to finding average value, whatever that thing we've been asked to find the average of, that's the part that's going inside of our integral as the function. Our general formula for average value is looking like 1 over b minus a times the integral from a to b of f of x dx. Whatever the thing is that we're being asked to find the average value of, that is what needs to go inside of our integral. In this case, because we're being asked to find the average value of the velocity, we're going to take that velocity function they've given us and plug it in here for f of x. It's a little bit messy, but in this problem, the average value function is given as p over 4 mu L r squared, big R squared minus little r squared. And we've been told to look at this from 0 to big R, which means out in front here, I'd have big R minus 0. One of the things, I need to have my d whatever, and in the words of the problem, it tells us to do this with respect to little r. So that means that this becomes a dr, and it also means that every other letter in this problem, we need to treat as if it were a constant. That means this entire part out front here can actually pop out in front of our integral. And then that leaves us with r squared minus r squared that we would be integrating with respect to little r. With respect to little r, this big radius is a constant. So if this just said 5 squared, then if I integrate that with respect to little r, I get 5 squared times little r. Again, moving that big constant out in front, p over 4 mu L. And then when we integrate big R squared, we'd end up with big R squared times little r minus, if I integrate r squared with respect to r, I'll end up with 1/3 of r cubed. And that was going from 0 to big R. Fundamental theorem of calculus says I'm going to plug in that upper limit and subtract off plugging in our lower limit. So I think I'm going to end up with 1 over r p times 4 mu L. When I plug in r here, I could simplify that to be big R cubed. And I'll plug in the big R here and have 1/3 of big R cubed. And then I should plug in the 0. I'm not skipping that step, but if we plug in 0, that will be 0, and so will this. So I'm not going to write that additional 0. We can simplify this. If I have r cubed minus 1/3 of an r cubed, then that's 2/3 of an r cubed. So I'd end up with 1 over r p over 4 mu L times 2/3 of r cubed. And taking that one extra step for simplifying, this r in the denominator would cancel out one of the r's in the numerator, and the 4 and the 2 would simplify, leaving me with a 2 in the denominator. So I think the most simplified form I could write this in would be p r squared all over 2 times 3 would give me 6 mu L.